I appreciate everybody jumping on. I'm Brad Watson. I'm with ZEDEDA. Spent a hearty 4 or 5 weeks with ZEDEDA, but have spent the last 5 years working with Dell Tech and VMware, very specifically in the IoT space. Really excited for this conversation, and appreciate everybody kind of tracking with us through the day. I go back to when I started in this space, and you already had building automation, kind of coming off of that Gartner hype curve and down into the quote unquote valley of adoption. And I think that it's still a really interesting space, and a space that allows interesting companies to be very disruptive. And I think we'll have a good conversation here throughout this module. So with that, I'm going to be quiet. I'm going to fade into the background. We want to introduce Brian Turner, who you may have seen on a previous session, as well as John Petsy. And I'll let you guys take it away. You tell me what you need from me. I'll be here.
Okay. Yeah, Brad, you're going to advance slides for us. Why don't you just advance to the next? So that's Brian and myself. We happen to know each other. Brian's one of our OEM customers, so appreciate the opportunity to be with him again. Once you go to the next slide, we're going to give you just a quick preview of the solution architecture here. But we're going to describe this as we go further through the discussion. But of course, we're talking about edge hardware with a platform. Our software, SkyFoundry's software, is loaded on the platform, and then Brian's company delivered a solution to a major OEM in the building automation industry. So let me comment on our role here. Next, Brad. So we're the software company here, and we make software that, as we say, helps clients derive value from data. We've been around for 10 years, fairly early entry into the data and data analytics space. And what we make is a software platform called SkySpark. And it's an analytics platform to collect data from the devices and equipment systems and sensors that we find in the built environment, and then to automatically detect patterns that represent faults and deviations and anomalies. And the whole goal is you're identifying opportunities for operational improvements and cost reduction. So what we help people do really is find the things that matter in the huge amounts of data that they have coming out of their systems. And our software is a complete stack, so it includes the data acquisition layer. Of course, that's important at the edge. A high-performance data storage component, database, the analytics engine, and the user interface to present results. So next, and Brian, why don't you tell them a little bit about Buildings IoT?
Sure. Go ahead, Brad, to the next slide. So Buildings IoT is really made up of 4 different wholly owned subsidiaries. We have ControlCo, which is a controls distribution company and also a SkySpark reseller. And then we have Kadaro, which is a software as a service, primarily focused in the buildings environment, providing analytics as a SkySpark OEM, or SkySpark is our actual analytics engine. But then we also provide that integration platform to integrate other business and building technologies so that a user can actually have a more rich environment that includes analytics plus maybe work order management plus maybe tenant access or something like that. So there's lots of different business applications that are cloud. So we focus on bringing the building data out to the cloud, and then of course connecting other cloud platforms as well. And the interesting thing we did that we'll talk about later with the use case does just that with SkySpark. So and then we also have OTI, which is a master system integrator. So they're working on deploying these systems and technologies in buildings and at the enterprise. And then we have our Canadian company, Buildings IoT Canada, which is where our main software development organization is. But we also have our managed OT services and IT services for the Canadian market serviced out of there. So that's just some background about us, and we can go to the next one. John, back to you.
Okay, thanks, Brian. All right, well, let's start off by reviewing why there's such a need for the edge and the cloud, both sides, because the IoT is really a distributed computing challenge, and I like to explain it with this example. The reality is it's not possible, it's not cost effective, and it's not even desirable to have to transmit every single piece of data from every device up to a cloud before you can do anything valuable with that data. And a good example of that is a self-driving vehicle. We can't be dependent on sending data up to the cloud to make the decision to turn on the brakes so we don't have an accident. That has to happen at the edge. But yet there's another example with vehicles that is better served at the cloud. We can collect the data from cell phone positions, bring that to the cloud, analyze that, and determine that, hey, there's a traffic jam here, right? Edge to cloud. They're both valuable. You know, I think we do a disservice if we try to say it's one over the other, right? There are applications across the entire stack. And in order to get there, of course, you need an IoT technology platform that embraces the distributed nature, the non-hierarchical nature, and has that embedded into the design of the software. Next. So I like to present a little example here because, you know, the fact is we are, as we're sitting here and talking, we live in a distributed computing world, isn't it? Here's a way to test that. You know, bring up your browser on your PC or your phone or your tablet, right? Next. Search for something you want, right? Go to Yahoo or Google or your favorite site or whatever, do a search and boom, you get the information you want. Let's think about that for a minute. How did that happen? Did you upload and store all of that information to your computer or your cell phone or your tablet first? No, of course not. Did somebody try to aggregate it all on one single server and they assembled it and stored it, had it all there ahead of time so that it'd be searchable, accessible, and viewable? And, you know, obviously the answer is no, right? Next. You know, you request what you want. You search for what you want. You subscribe to the news feeds that interest you. You get that data, but you don't try to aggregate it all in one place ahead of time because you can't, and also because there's no need to, because, you know, there's nothing on the web that actually works that way. But yet, next, we ask the question, why do people think that you have to bring every piece of data from hundreds or thousands or millions of devices to a single server first before you can do important things with it? Analyze it, visualize it, present it, make control decisions off it, gain value from it. And what we find is that because the cloud is such an important technology, valuable technology, people just fall into a kind of a, you know, well, that's the way it's always been done mentality, right? And they're not fully aware of what is possible when you implement a true distributed architecture for the IoT from the edge to the cloud. So next. So let's talk about, you know, what we mean when we're talking about edge to cloud and what that provides, right? The first thing it means is that your data collection, your storage, analytics processing, visualization generation, report generation, notifying operators, etc. That happens not only at the edge, not only at the cloud, it can happen at all levels of the architecture. Now, I was in a session earlier where they were talking about how the edge is numerous different things, right? It's the very edge, if you will, out on the equipment. It can be the edge data center that's closest to a process, right? And then, of course, the cloud, right? So we're talking about being able to do all of the functionality. In other words, run all the stack at all levels of the architecture on many distributed compute nodes. And then those compute nodes have to be able to work together in a unified, seamless system. We use the term clusters for connecting these nodes together, whether they're small embedded devices, whether they're network level controllers, whether they're gateways to pull data in from proprietary protocols, whether they're on-premise servers or they're cloud servers. When we talk clustering, we're talking about connecting them all together in a unified view that provides a user environment that's seamless. So the user doesn't worry about how many processors it's distributed on, what the IP addresses are. They just view what they want to view, and it's there just like that search I did on the web. I didn't worry about what servers gave me the answer for, you know, a restaurant I might want to go to tonight. And the goal here is that we want to provide flexibility, but scalability, reliability, and simplicity, and be able to do those things that have to happen at the edge. And it turns out you have to architect software for that. You don't just take cloud-based platforms and stuff them in small edge devices. Next. So what I want to show you now is an example of our technology in a distributed architecture, and that's small colored icon you see on the bottom right. You'll see it distributed out throughout this picture. So let's start at the cloud level, right? Our technology allows you to have multiple instances, multiple nodes at the cloud level, which allows you to scale to huge size systems. My technical guys won't let me say infinite, but very, very large, right? But then let's go down to the bottom of the picture. We're in a facility, and there's an on-premise node running the full stack that's connecting to the devices in the building. Now, it might be connecting to devices that have protocols that are not well suited to go over the internet. In other words, aren't secure. It might be talking to a whole variety of different protocols, and it collects the data, brings it together, performs the analytics there, right? And so then what goes up over the network to the operator, look at the screen there on the right, the only thing that needs to go to them is the end result. And what we find is in these types of architectures, the bandwidth, the amount of data that has to be transmitted over networks can be reduced by 100 or 1,000 to 1 this way. Now the operator doesn't know. They get the results they want, but they didn't have to have every piece of data sent right to their PC or a server. Next, if you look at the green section of the architecture, we're seeing that icon on small pieces of equipment, and this is where the discussion's leading. Our technology is designed so that it can be deployed on small, low-cost IoT edge processing equipment, as small as a Raspberry Pi Zero. Of course, we're typically talking about more industrialized pieces of hardware. Next. So that's all great, but it's a fair game to ask why. Why do we care about distributing an architecture like this? Well, the first reason is for greater fault tolerance, right? And fault tolerance is more than one thing. It's for data collection, right? We don't want to stop getting our data, stop processing analytics, and getting important information because of the internet being down between the building and the cloud, right? We can't live with that. There's many mission-critical applications, right? So that's one way it provides greater fault tolerance. The other is for the in-building personnel. You don't want someone who's sitting there in an equipment room looking at a major piece of capital equipment and they can't access the data from it because their connection to it has to go up through a cloud first. So those are two areas that demonstrate fault tolerance. The next is low latency. In other words, real-time or closer to real-time. There's numerous processes that have to happen where the latency of going to the cloud is not viable. Another key reason is to support applications with what we call constrained networks. Now, that might be networks that don't have high bandwidth or throughput. It might be networks that have intermittent connections, so they're not that reliable. But there's another type of constrained network, constrained by cost, right? Cellular connections can be very expensive to send vast amounts of data over. So if you use this architecture, as I mentioned earlier, the only thing that has to go up over that cellular connector is the final answer, right? The end result, the analytic finding. Next. So some other reasons. Security, keeping data on-premise. There are many cases where in order to meet project requirements, they simply can't have an external connection to a cloud or send their data to a cloud. Another part of security is isolating those in-building systems from the internet. It actually acts as a security barrier because in many cases, those protocols were never designed to go securely over the internet. And other examples are purely to meet regulatory requirements, right? That the data from a certain customer must stay in that legal jurisdiction, that country, that region, whatever. Another reason, of course, is then with this architecture, you end up reducing costs because you can eliminate, in many cases, gateways and other security appliances. The software does it all, right? And another real important advantage is reducing costs by engineering once, right? You set up the data acquisition at the edge. You set up your tagging of your data when you implement the edge device, and it's done and carries through the entire architecture. And then, of course, the final reason is we want to and need to provide a seamless user interface to the end user. Next. All right, so that's all great, but in order to implement these highly distributed systems, there are things we have to do. There are challenges, right? And the first one we'll talk about is replication. If we have all that data spread out all the way in all these different processors, where do we back it up? How do we make it available to people? And the concept we use a term called replication. And what that means with our technology is that you can, when the networks are available, replicate the fully operational replica of each node up into a cloud, right? And you can even do this over limited networks when they're available. You can replicate, and it's not just the data or not just a backup. It's fully operational, meaning operators can issue queries to it. They can get reports out of it. They can do everything they would have done talking to the edge node. They can do it with the last available data. Next. Let's just take a quick look. We saw this picture, right, earlier. That's the edge to cloud platform. Now let's overlay it by showing the next slide. And now here we're seeing the replicas. You can have a replica in building on premise. You can have replica in building on premise of all the embedded devices that are running the software. You can have replicas at the cloud. So it actually goes beyond the concept of a digital twin. It's many, many digital replicas of the data. So it solves that key important challenge. All right. Next slide, please. So as I mentioned, when we're talking about going all the way down to the edge, we're talking about running the entire stack, the full application suite on small, low-cost IoT hardware. We've designed it from the ground up to do that, and you can see the specs there on our minimum platform. And the next part of this presentation, I've got one more slide, will be Brian's group showing a OEM implementation for a major equipment OEM called the Belimo Clear Edge. Next slide. So the next part of the key challenges for these highly distributed compute architectures is provisioning and deployment. And that brings us right back to where ZEDEDA comes in, right? You need to provision both the hardware layer applications, the operating system, the VM, et cetera. You need to provision the application layer, our software. You need to manage security requirements, the OS layer, the application layer, et cetera. And that requires technology. And so that's where ZEDEDA comes in. And now for the rest of the presentation, I want to turn it over to Brian to get into more detail about the very unique application they've built for a major OEM. Thanks.
Yeah, thanks, John. So give you a little bit of background. So John talked a lot about the SkySpark platform and how it's designed to scale edge to cloud and cloud to edge, and solve a myriad of problems depending on what the application is. It really isn't focused on any one application. You can design it to solve problems across the board. So one of as John said, we have the Belimo Clear Edge story that we're talking about, and what Belimo's challenge was, hey, we have all of these devices that sit inside of a building. And when they originally thought of it, they thought that, hey, people will just connect all of our devices to the IT network because IT and OT are converging, and they're very happy to have OT devices connected. And those devices will just directly report to our cloud, and we'll be able to provide some information, some valuable insights and information about our device's performance for those customers. And as it turned out, organizations weren't really fast to actually connect all of these devices and allow them to just, send their data out to cloud. And there's a lot of reasons for that. But one of the biggest reasons was just, look, we're not going to maintain the number of switch ports that would require. And so we looked at an alternate solution was to provide some sort of gateway that could connect these devices on a serial network and then aggregate that data and send it out. But then there was also this opportunity of how do we get this set up? How do we run maybe some of the value we thought we were going to provide in cloud? How do we provide that value on-prem? Can we incorporate some analytics, et cetera? And so we, as a SkySpark OEM, delivered a solution that was put onto a small platform that they call Belimo Edge, and it solved a lot of their use cases. And then the next challenge really comes. And so that next challenge is, okay, great, we've got SkySpark running. It's all branded for Belimo. It sends it out to Belimo's cloud. This one shows it going out to our OnPoint cloud, which it could go both directions. For all that matters, it could go to both clouds. Or Belimo didn't actually want to worry about that. So it was if somebody wanted to go to OnPoint, they could go from Belimo's cloud to OnPoint instead of direct. But really, what's the challenge next? If I really want to scale this as Belimo, how do I scale it? I intend to have thousands of these devices out there connected, all running the same thing. And so we said, hey, great, we've got that solution, because with SkySpark, we can keep the SkySpark licenses and the version software and the modules and all of that stuff up to date. And we can remotely manage all of your SkySpark instances from the cloud. And this is where really the next iteration comes in, right? Can we go to the next slide? And again, this just talks about, okay, here we have the multiple deployments, right? All coming back to cloud. And the next slide. And so now, really the next part of this is incorporating ZEDEDA. And so I've been talking to Jason for a long time, Stevenson, his days prior to ZEDEDA, about how do we actually manage or future-proof this so that I can manage the operating system, so that I can manage security potential problems in the future. So it's not just about managing the application in this case, where I can, SkySpark's given me all of the ability to manage that. But now how do I start managing the device, the ports on the device, the operating system I'm running in? If I want to run in Kubernetes, how do I do that to create some sort of localized high availability? So all of those kinds of challenges have been problems we know are coming. Today, Belimo has a few hundred of these boxes out there, but what happens in 2 years when they've got thousands, tens of thousands of these devices, and a security flaw is identified in the underlying operating system? How do we manage that? And so that's really where we're pretty excited about what ZEDEDA has to offer to us in that realm. The other thing that's pretty exciting is this ease of deployment. Right now, we think we've got a pretty easy deployment. We worked very hard. SkySpark's given us a tool that we could actually create a user experience as well as this underlying control engine and analytics engine. But we actually were able to create more of an appliance-driven user experience so that when the contractor goes out to set up this ClearEdge appliance, they can just launch it locally. They don't have to connect to cloud. They don't have to have a live internet connection, because a lot of times these are deployed on construction sites, and you don't have all of that. So they are able to just launch it locally, completely set it up, and get it completely operational before it ever connects to cloud, which is a pretty nice feature. However, in the future, when cloud connectivity is more ubiquitous than it is today, and when IT deployments are actually more commonly in the construction process, where you actually have a fully operational IT infrastructure that's ready for testing and commissioning of a system, then we're going to have products like this that'll be much more available, because now ZEDEDA can create that secure connection to the ZEDEDA cloud. We can create that root of trust. We can now allow people to even more easily, so I don't even have to have them go through the setup anymore, because all of that's automated anyway. If you connect the devices, the appliance itself will find everything and bring it in. It doesn't need a human interface. And if you go to the next slide, one of the exciting things that ZEDEDA is going to offer is I can send this device out to the on-prem. They can open up an application that will connect to the ZEDEDA cloud on their phone, take a picture of the QR code or on the device itself, that will register it to that device. And then what it can do is then go and download the application, or they can even say, I want to install the Belimo Clear Edge on this device. And now that device gets all the application, the latest operating system, the latest security updates, the latest application updates, all right in there. And that on-prem contractor really doesn't have to know very much, except other than how to connect it to the platform. Then they also can take a picture of it. It automatically captures the GPS, and it's done. It can then notify us that, hey, this is ready to get turned on live. It can notify Belimo that we just got a new Clear Edge gateway attached. And so this is kind of a next generation of where we can start taking these appliances. And you know, a lot of us have solved these problems in a one at a time or even a 10 at a time type solution. But what we're really excited about here is we can start solving these problems at real scale. So where we can actually plan to be able to manage and remotely manage tens of thousands of devices across the world at any given time. We've got a security update we need to do. We can schedule them, right? We can get them to automatically go through and do everybody's without having to contact 10,000 clients and have them all do it themselves. So pretty exciting stuff. Go ahead to the next slide. And we're really excited about this opportunity. Obviously, we've done a lot of work with John. As John said, we're very familiar with each other. We've done a lot of work together. I think we're ready to summarize this up. So I know we got a lot of time left in our session here. That normally happens with me and John, but we're certainly open to any questions that you guys might have and want to put in the chat window. We'll do our best to get them answered.
Yeah, I see a question here that I thought was interesting. I think we both may want to comment on. For managing highly distributed systems, for example, government buildings in different regions, is it possible to monitor, manage, maintain from a central control center, right? There are natural cost efficiencies there, and we're starting to see demand for that in precision agriculture and other areas. So the first thing I'd say as far as the question, yes, it is. And I think, you know, Brian and I both been involved in managing large-scale applications from a central location. The thing we're talking about here is making it dramatically simpler and easier and more reliable, right? But yeah, that's a key part of what we've been doing with both our companies over the last 10 years or more. It's interesting you mentioned precision agriculture. That's a segment that we see as a growth segment, pun intended. Those are industrial processes. If you've ever had the chance to tour any of those facilities, they're industrial processes, and the data is critical because if you don't see a problem happening immediately, the impact, financial impact to the crops is significant.
Yeah, and to address kind of the larger buildings, whether they be government or education or commercial high-rise or kind of any group or buildings, we certainly do manage those remotely or from a central interface and control center. What we're seeing and what we're actually working on with our software technology is you know, it's one thing, legacy, you've been doing that for 20 years, but it's typically been with proprietary technologies. And once you bought into a solution, you were bought in for the life of that system, really. It was very hard to migrate from one solution to another. And so what we're really part of is this next wave of innovation that includes using a lot more open standards, right? And so connecting, not trying to replace a work order management system or become the work order management system, for example, but instead just attaching to one of the 100 different cloud solutions, whichever one you happen to like, whichever accounting system you happen to like, whichever analytics platform you happen to like. And what we're starting to do is aggregate these different solutions, whether they're on-prem solutions or cloud solutions, and really starting to show that these architectures can be very much like your cell phone. You know, John used the car analogy earlier from autonomous vehicles. You know, there's also the phone, which has many, many, many applications. And if you don't like one, you just delete it. And this buildings world is very much heading that direction. And you know, these type of technologies just even closer to reality. So But yeah, absolutely, we definitely are handling these highly distributed systems, and it's not just the building systems. It's many of the operational systems going within. And with the IT convergence, we're starting to see real convergence around the user stories and what a user can really interact with on their daily experience within these applications.
Yeah, I was going to pop on really fast. I wanted to dig into that idea a little bit of this. There's been an awful lot of talk today and often in these conversations around this idea of IT and OT convergence. I live this in my own household. My wife is an IT director for General Motors in the manufacturing space, and I can tell you that there is a constant struggle between like the IT and the OT, even at that, not shocking and maybe surprising at that size of company. But do you see that as both challenge and opportunity? Is it something that slows down certain implementations or projects that either of you guys run across out in the space?
Brian, that's yours.
Yeah. So as I said, we spent a lot of time deploying projects as an integrator and working with multiple disciplines and multiple different system contractors to deploy these things. And I won't say that it's not a challenge. Now that IT and the network infrastructure is way more IC centric, and it's few years, as 2 years ago, they were talking about having, you had a separate OT network, so you could install that during construction, and then maybe you would connect it to IT down the road, or maybe you would just end up with these parallel, networks, air gapped, and IT doesn't care about OT. But that's not the answer, right? There's tons of value, way more value than there is hurdles to clear in having converged networks and having a converged security plan and having a converged technology plan. And so what we're now working with as a master system integrator is really bridging the gap between the IT and what they need to do for their own planning from a traditional IT perspective, and what they need to do for OT and all of the operational technologies, especially during a construction project, right? So if I've got to start testing devices and systems and interactions within the building in order to turn it over, I'm starting to test that stuff with some of these longer projects 6 months before turnover, right? So that means that my full IT infrastructure has to be installed 6 months before it, so that all of these interactions can actually take place. And that means that on the general contractor side, I've got to have clean rooms set up. All my IT labs have to be conditioned and clean way earlier than I ever anticipated before. And so it really does, change the way people are looking at projects. The good news is we've been able to work with several general contractors that have been able to make these adjustments. Once we come in and educate, hey, your HVAC controls look like this, your electrical systems look like this, we've got 150 IP ports for this, we've got 25 over here, we've got another 2,500 in your lighting, we've got 700 IP connected cameras, I've got 1,500 IP connected doors, right? So we've got all of this stuff, I've got all these ports all over the place, we need it done fast. And the other thing that I like is IT has recognized, and a lot of organizations, that they don't have to be one size fits all, fully control. Everything has to be one platform to be a converged network. And they're starting to recognize that maybe it makes sense to have components of their network that are dedicated and tied to OT, to security, to HVAC controls, whatever it may be. But at the end of the day, the only way that those things access the cloud or all the security permissions, those are then applied by the IT group. And so I think it's going to continue to get smoother. One of these questions was about, what happens during construction site. We've got a lot of color around that. So I don't know if you have specific questions how this is going to get fixed, but we're definitely seeing a lot of movement, positive movement in that direction.
Awesome. And Cynthia had a great question too. I appreciate that answer. But her question around data ownership and how is that being shared with the OEMs, and what are their concerns?
Yeah, I'll start with that and then let Brian jump in. So what our experience is in this industry is the facility owner owns the data. And it's an expectation that even many people who provide the service as a cloud-based service have to accept the fact that that building owner owns the data, and the data, if they want to take the data someplace they can. One of the things we do with our software is make it very easy for people to take it out in a whole variety of standard, well-documented formats, so they could move it to other platforms. I have not seen, anyways, the idea that all of the data from all these pieces of equipment will magically go to all their OEMs so that they can improve their products. I don't see that thinking having taken root in our industry yet. I don't know, Brian, I mean, you did something for an equipment OEM, but, that's different than is all the data going to flow to them, just kind of, with my cell phone, I know somebody's got the data, I just accept it. I don't think that same level of acceptance is found in facilities management.
I was having a conversation earlier today about this topic, and so ownership, I 100% agree with John. From our perspective, the ownership is the building facility owner. Wherever the data is collected, who owns that part is who owns the data. And so the real thing is also, as we start talking about buildings, is does any of this data that we collect contain PII? Now, the application that I talked about earlier doesn't, right? There's, it's about a product, and it's about specifically how that product is operating. It's actually not about really anything else, and certainly not PII. But as you're starting to look at all of these different systems that are being deployed today, whether they're using ZEDEDA or any other type of technology under the hood, they're potentially collecting PII. And there's definitely a lot of conversation going on right now about how that data is transported, who owns it, who's allowed to access it, how it's secured, and I have talked a lot about this in the past, but in a lot of ways, our industry, at least the one John and I grew up in, is we spent a lot of time trying to open data, unlock data from proprietary protocols, and getting into BACnet, LawnWorks, even modeling it with Haystack and trying to get data more and more open. And all we've done now is actually lock it behind APIs and security, and just locked it all up again. But now we've got this other problem of we didn't used to care about, or we weren't as concerned about collecting all of our personal information as we are today. But John mentioned the cell phone. The cell phone knows a whole lot about us. And unfortunately, so do a lot of other things. And so I think that who owns the data question is definitely going to get much more broad. The conversation that happened this morning on PII specifically was in California, where I live. There's been a lot of legislation that has specifically targeted the use of cameras and especially for occupancy control and monitoring, and prohibited it really from doing that. But enter COVID and enter 2020, and we're talking about giving up our privacy in a lot of ways in order to do tracking, and obviously it's opt-in. But I'm curious now with COVID and just the whole idea of another pandemic hitting, what we're going to do as a society and how it's going to change our perspective on what PII should be shared and what PII shouldn't. Because we were definitely trending down the path that if it at all could possibly have PII, it couldn't be collected and stored. And now I think that conversation's reopened. So interested to see where that's going to go.
Well, I know we're getting up against the stop here. We've got a few more minutes before the next sessions start. So I don't know, Brian or John, if you, Cynthia's got some great questions in the chat here that continue to flow. If you guys want to keep addressing.
Yeah, Brad, I'll quickly answer that last one. Have we seen an application where people are trying to implement stuff with COVID. And I won't name the name, but there's a big building operator, building owner, developer who is implementing occupancy sensor technology that is not camera based. It's got a different technology, so it doesn't collect PII. But they're actually using it and deploying it simply in their lobbies, in their elevator lobbies, and they alert security when the elevator lobby has more people than can be in there per social distance guidelines. And then they're also talking about, and this hasn't been approved yet because of the elevator, from a codes and ordinance, but from a solution standpoint, they're like, it'd be great. We have an occupancy sensor or a counter in the elevator. And if there's more than 4 people in the elevator, which is all that can max be in there according to social or physical distancing, we just won't let the elevator doors close. And so you basically force people to exit the elevator so that the 4 people can actually move. And then they're using technology by changing, a lot of the elevators in buildings have been programmed to be more energy efficient and only use the one that is closest to the floor being called. Well, they're starting to think about overriding that kind of logic. And actually, if there's more people in the lobby and because we can only take 4 people at a time, we need to engage more elevators. They're now overriding that energy efficiency logic with let's just get people moved because now we're not allowing as many people in the elevator. So we're definitely seeing COVID-19 have a dramatic impact on the way we operate facilities. Haven't seen it yet in higher ed and government, but in the private buildings world, I've definitely seen that.
Interesting. I was talking to a neighbor friend of mine who is a VP of Salesforce in the HR side, and they're talking really specifically around the idea of a boarding pass, right? So like essentially a printed or a mobile boarding pass on your phone that is your ticket to entry into the building, and it tells you which door to enter through and which elevator bank and all of those things. So some really interesting things that, I think about it relative to schools. Like, there's a lot of interesting things that are being thought of that we hadn't thought of prior to maybe, the 1st of March. So it's interesting to see some of those innovations be born out of a crisis. So, well, I know we're definitely up against it. This is an awesome conversation. Thanks to everyone that joined. Brian and John, thank you for the really valuable insights. I knew this is a conversation that's going to continue, certainly offline, and we look forward to the partnership with both of you. So everybody, appreciate it, and we'll give you the opportunity to jump into a few more sessions. Some great content left this afternoon.
All right. Thanks for the opportunity to participate. Appreciate it.
All right, guys. Take care, everyone. Thank you.